title of this song reflects pretty well what I'm going to tell you later on. So we got songs as the main theme. We got cries. You will understand when it's time to cry when you're in the field and you're doing some field work and something is going to go in the wrong way. And then there are some lessons learned while we were working for 15 years, more than 15 years in Madagascar. So you'll see these reflected in the slides I'm going to show you today. These are some of the speeches I've been working on over the last 25 years now, more or less. But among these speeches, I always have had a love for lemurs. And lemurs are great because they live in very different environments. They are very different organization, very different mating systems, and they are also cute, which is something very important these days for research, you know. And as Florence said, I'm coming to bioacoustics from a different field, so the best slogan for this thing is lemurs rock, okay? So this is basically what I'm always telling me. And when I moved from a record company to bioacoustics at the university, it was like changing the field from black and white furry animals like these ones to another black and white furry animal like this one. And what was very interesting is that in these three cases, they are all singing. And singing is something very special. And when we think to singing primates, sometimes we can be wrong, but still, there are primates producing song. And this is something more for the students than for those that are a bit more experienced. But if we think that all these are primate species, the primate species we know, only those highlighted in a sort of a pinkish color over here are those that are giving song. So singing in primates is something quite peculiar, quite special, that we cannot find in all species. And if we throw these icons on a map in the table, we'll get something like this, right? We'll get that most of these species are around here. Then there is a species in Madagascar, and there are maybe a couple of species in South America, right? And when we put images over these maps, we got the Columbina in the Pithecidae family in South America. We got the Lobatidae and Tarsiers over this area, and we got Indris in Madagascar. So because of the distant phylogenetic relationship between these species, we think that singing and singing behavior have evolved several times independently in the order of primates. So we focused our efforts over the years on this animal. Indris are legendary animals in Madagascar. All of you that have been around Madagascar probably know that there are a lot of tales, a lot of legends around these species. They are considered really special among lemurs, and they are also one of the flag species when we are thinking of lemurs in Madagascar. They live in the mountain rainforest of eastern Madagascar. This is one of the places of my heart, because when I'm there, I really can enjoy nature. And of course, what happens is that these forests are really endangered because of the human pressure on the forested areas, right? We've been studying Indris in the southern part of their distribution, basically the area that is squared in red over here, but particularly in the neighborhoods of the Montedian National Park that you can see more or less from the map, and in particular in these four areas, Montedian, Mitsinzu, Analamasutra, and Marumiza, that are very important areas for the protection and the conservation of Indris in Madagascar. What we've been doing over the last 17 years, more or less, is trying to investigate. And when I say investigate, I mean quantitatively investigate the behavior of the species. There were a couple, let's say 3, 4, 5 papers before we started studying the Indris. Very interesting papers, and they were telling a lot of things that we actually verified in the field, but there was some lack of quantitative data. And what I think it was a daunting task sometimes over the last years, and brought us many cries and many late night works, was that in many cases there was a missing of data that could not be actually found in literature. And so what we worked on over these 17 years is to monitor the behavior of these 20 groups over the 4 forests that I presented before. Of course, we have not been able to sample all groups every year for these 17 years, but we did quite a lot of work, and over the last years we concentrated a lot on the groups in Maromisa, that are those that we are still hopefully studying from next year onward. And we know that Indris are living in are pair-bonded species, but we also understood over the years that they may have up to 4 offspring living in the group. So these family groups are moving around different patches of forest, usually more or less all together. They are feeding, they are defending their territory, as we will see in a short while, and they are providing very loud songs more or less every day, at least in some seasons. So the first point that we concentrated on was the description of their territoriality. And we knew from previous works that they were thought to be territorial, so there was some way an information related to their territorial behavior, because they were seen defending a territory at the borders from other groups. But there was a lack of information about the exit path they were following, and there was a lack of information about the actual variation of those territories over the years. So whether they were occupying a precise area, and this area was changing more or less every year, or so they were moving altogether over different places in the forest. And what we actually found, and you can guess it out from these very tiny white lines over the black background, is that they were actually occupying stable areas over the years. And what was very interesting was the degree of territory exclusivity was very high. And when we take the overlap in between different territories of neighboring groups within 1 year, this is less than 5%. So this tells very well that there are indeed territorial exclusive primates. Another thing that we were interested in understanding was whether they were defending their territory. This again is something that was reported in some papers about Indris, but there was a lack of information about how often this was happening. And so we followed the animals, of course. We were running after the animals, and I'm not the best one in these last years, but anyway, somebody did that, and also somebody in this room. But we were able to understand that over these 17 years, more or less, this is the total number of fights that we recorded, vocal fights or physical fights. And when we divide that by the month of work we spent in the field, more or less we have 1 encounter every month. And I'll come back to this in a short while. But before coming back to this, let me show something, thinking on the long-term sense of recording data and collecting data for many years. So if I take data from the first year of work for this kind of data I'm presenting now, that I'm telling you in a second, this is the estimation of the mean home range, and this is the estimation of the mean distance between centroids of the territory between different years. And I add data from all the following years, right? So this is the first year, second plus 1, and so on until 2020. I see that there is quite a variation in the average value that I take. Of course, this is a result of studying different groups, but this is something that we can take in our mind when we think of following a species for many time, and when we think about describing something which is actually reliable for the behavior of a species. So you see, for example, that there is a decrease at some point in the average value of the territory home range estimation, and then there is some increase in the last years. So you see that adding more data, you more or less come back to a different value at the very end of this work. And same for the mean distance of the centroids. At the very beginning, it was something like they were not moving so much in the forest. Then there was a decrease when we added some groups. Then there was again an increase. So we don't know if this, of course, is caused by environmental phenomena, but we know that there is some way a change across the years that we have to take in mind when we want to describe something which is, as I said, species-centered, right? So the first lesson we learned is that long-term data collection may provide critical insights into biological variation. Let's go back to the fights, right? The vocal fights and the physical fights. One encounter every month is much less than what was recorded for other singing primates. So we got data for gibbons, for example, that are meeting much more often, actually, than once a month. And so we wanted to understand why they were so few. I mean, why they were meeting so rarely, right? And fighting so rarely. And of course, the good candidate to understand why they were meeting so rarely was the song. Providing songs, probably, as it was described, for example, by Alban and colleagues about howler monkeys, may be, of course, important to keep the spacing in between the different groups in the forest. And we've been looking at, we've been observing at what the animals were doing when given these songs, and we found that there were 3 different songs. I mean, when we look at these 3 different songs, if you are not really into bioacoustics, probably you'd say, okay, the general structure is very similar, and it's true, but I think that if you look in more detail what I'm showing there, you can understand very well that there is some difference, right? There are differences, there is a difference, let's say, density of the different units given during the song. And actually, we were able to show that these differences were actually associated with different behaviors, so let's say with different situations that we could describe. And one was that when they were given these cohesion songs, which is an intra-group communication, it's when they were dispersed during feeding in the forest. And so when they were giving the song, after the emission of the songs, they were far away one from another, and they were regrouping at some point in the forest. What was happening when they were giving the advertisement song is that they were in visual contact with one another in between the different members of the group, and they were vocalizing together without them moving far from the place where they gave the song. And again, when they were fighting at the boundaries, they were giving a different song in which a lot of overlapping between the different individuals was happening. There was a very active movements of all the animals across the different branches and the different trees. What happens next, after this slide, is that I'm forgetting the cohesion song and the territorial encounter song, and I'm concentrating on the advertisement song. Why? Because the advertisement song is given more often than the other 2, and so the sample was larger. Not just because it was the most interesting. I mean, also the other ones are very interesting. Let's have a video. In this video, you'll see one Indris singing, but actually, the Indris song is always a chorus. So you have different animals in the group, the paired male, the paired female, but you also have the sub-adult and adult offspring singing together. In this video, we look at one individual, but you can hear the others in the background, right? Okay, what we call the advertisement song. We call the advertisement song a series of different elements that is given in that particular situation I was telling you before. The advertisement song is a complex sequence of utterances, as I said, in which all individuals within a group, all adult and sub-adult individuals, are giving the song. So the first part of the song is a roar, which is a very harsh sound, is a series of very harsh sounds, and this is always given before the start of a longer part, which is built of different units that are modulated in frequency. Over here, you see the fundamental frequency of these different units given by different individuals. As you can see from the picture, we have long notes that are given at the beginning. Usually they are very long when they are given by males. And then we got single notes, so elements that are given alone, not in phrases. And then we have a very particular series of phrases, which is given with the descending frequency. So the second or the third or the fourth unit is always starts at a lower frequency than the one before, right? These are called the descending phrases. They were called so by Talman in a paper of early 90s. And we can have phrases of 2 elements, of 3 elements, of 4 elements, and also 5 and 6, but 5 and 6 are much rarer than these 2. So I'm really flying high over the methodology, but I want to stress the fact that one of the key points that allowed us doing a lot of things over the years was recognizing the contribution of each individual. So this was really a key element in the study. And I'm putting colors over the different animals singing in this part of the song. And of course, this allowed doing a measurement of the units or the total phonation and the duration of the total contribution of the particular animals. And of course, starting from these, we were able to isolate also the different fundamental frequency of these modulated elements and to study in detail the acoustic structure of those elements. So you can understand that, of course, these are gathering a lot of information about the acoustic variation, a lot of information about the contribution and the variation of the contribution over the years of the different individuals. So this was really a key element of our study. And one of those things, since the very beginning, we were thinking about is, wow, this song maybe can provide information about the sex of the animals. We had in mind gibbons. You know, gibbons are strikingly different when you think of males and females. And with the Indris, we didn't know so much. But the guides, the people from the different villages working with us in the forest was pretty much convinced they could recognize males and females. And so we said, good, so let's look for sex differences. And so what we've done basically is to measure the different acoustic parameters for males and females. And first of all, we understood that the individual contribution of males and females during the song actually was not different in the total duration. So they were contributing the same amount of phonation during their singing in the song, their individual singing in the song. But the picture is different when we look at the number of elements. So the number of elements is significantly higher for females. So this tells us that the average duration of males' contribution is much higher, of male elements, is much higher than female elements, right? And another thing that we wanted to look at was the number of elements in phrases. And again, we didn't find a significant difference in the number of elements given in phrases by males or females, but we found a difference in duration. If we consider the duration of phrases is significantly longer for males compared to females. And of course, this suggested that we could compare the different elements, the different units given during the song, and we could actually measure the duration of each of these units, the long notes, the single notes, the elements of the descending phrases of 2, 3, 4 elements, and see whether there was a dimorphic evidence in between males and females. And what we actually found is that only 3 of these elements are really showing significant differences, and these differences are related to the long notes, to the first unit of the descending phrases of 2 elements, and to the first units of the first unit of the descending phrases of 3 elements. One of the big issues, there are a couple of very nice papers published, is that we know that in humans we have a dimorphic pitch when we compare male voice and female voice. And so there was a lot of people thinking, oh, let's look about primates. And in primates it was impossible to find these differences, this difference in pitch in between males and females. And actually Indris are some way confirming this evidence. So when we look at the fundamental frequency, the fundamental frequencies did not differ significantly in between males and females. There is a tendency of males to provide in some parts higher frequency notes, but this is not significant. Again, looking in the long term, it was nice. Actually, I did this for the purpose of this talk because I have not done this before, but it was very funny to see the variation in some of the acoustic parameters when we add all the different years of recordings that we did to the first year of recording. And so when we look at duration, mean fundamental frequency, and range of the fundamental frequency, this is basically stable. This is very important. Because in the future, if we want to go and study new populations, we can imagine that even if we study them for 1 or 2 years, we might have something that can be put in the picture. And this is very critical, very important to plan future research. Another aspect that we wanted to compare in between males and females was phrase concatenation. So we knew that animals could concatenate the phrases in a different way in their songs, and we wanted to see what was happening for males and females. And what is very funny is that we see that the males are always starting their modulated notes, modulated elements part with a DP2, a descending phrases of 2, and they provide a series of DP4 and series of DP3. When we look at the females, females are providing series of single notes, and when they give a DP5, it is followed by a DP4 and a DP3. So clearly there is a dimorphic kind of concatenation of the different phrases in the song. A dimorphic kind of concatenation that we wanted to evaluate with the average Levenstein distance. And I think some of you might be familiar with that, others not. Please ask me later. But still, this picture tells you that females, the orange bars, are higher than the blue bars of male. And this is telling you that females are more variable when compared with themselves. So they are providing sequences that are more diverse in between other sequences they still give within the individual. So I'm a female, I change my song more often than what happens for males, right? And when we look at males, we see clearly there is a significant difference in between these two. But it's also true that when we compare females between individuals, we have a higher value. So females are more distinctive when it comes to their concatenation than what happens in males. This is very important because later on we'll see some other evidence that can fit pretty well with this one. So, one of the last studies that we've done is to try understanding whether we could describe quantitatively the change of the song during subadulthood and juvenile stages in the Indris. This is something that is very difficult to find in literature, because a lot of information about gibbons and the different species of gibbons is quite limited in terms of number. I'm not saying that it's easy to have big numbers in the Indris, but still we were able to understand that intervals between phrases are actually changing dramatically during development. So we see that males are starting at a higher level and then they go down, and females are starting at a lower level and then they go up. And same happens for no duration. When we adjust for the type, we see that females are actually going higher and males are going instead to shorter calls. And this is very important because, again, this can tell us whether these changes are critical for the adulthood, for the development of an adult song. Another thing that we investigated over the years was the acoustic variation of phrases compared with the genetic relatedness. So we were able, after a lot of work, and we were collecting poos around the forest. It's a very great work, and you can enjoy it a lot. And all right, we were able to understand that those that were supposed to be family groups, they were indeed family groups. And this is something that, okay, you say, okay, it was already supposed, yes, but when you have evidence, it's better than when you think it's like that. So basically, we were able to understand that when we look at a family, at a group that is living together, very probably that's really a family group. And we wanted to compare with that information, the information that was coming from a variation of DP3, DP2, DP4, and we started comparing the first two units of these phrases. I'm not showing data for the DP4 for brevity, but I'm showing the other two. And what the other two are telling us that when we compare sons with fathers, we see that we got a lot of significant results. So it really seems that sons are more similar, or let's say potentially they inherit some information from their fathers. When we look at daughters against mothers, this is not what we see with the same amount of information. There's nothing behind me here, no? Okay, so we got a significance, but just for one of the parameters. And when you see the parameters, they are both temporal and frequency parameters, right? Then I said cries, right? And I should tell you something about cries. So a key element of working in the field is the contribution of research guides and of students of the countries in which we study primates, right? And what was very funny is that we lost 1 year of data because, not these two guides in particular, but the guides we were working with actually couldn't recognize the sex of the animals. So we lost a year of data because of that, and we said, okay, we got to have a photo book of the genitals of all these individuals. So we have a lot of books that we keep for ourselves, but if you want to have a look, you can ask, for the genitals of all the animals we're studying, right? And because we have those books, we can tell you about this lesson we learned. Believing what others tell is comfortable. Verifying what others tell is wise. But unfortunately, you cannot read here. This is a great chance to grow together. And this is what we've done over the years, trying to build capacities with the people we work with and empower them of doing new research, which is something very critical. Imagine the COVID-19 situation. We cannot go to the field anymore for a while, but we might have people over there that is collecting data and continuing the picture, the mosaic of this information we can put together. So then there was something that came to our mind at some point. And we wanted to understand the rhythmic patterns in the Song of the Indris. We know that rhythmic patterns are very interesting. There's a lot going on here, but I'm sorry, I cannot show it to you, okay? A critical aspect of animal rhythms is to understand, of course, the degree of flexibility at a specific level. There were a lot of studies in the 90s when I started studying, I was very young, you know, but I started studying primates, and those studies very often were describing species-specific variation. One species has a rhythm, another species has another rhythm, right? The problem is when you think about variation. And when you think about variation, you see sometimes a different picture. So we decided to look at the rhythm of the different phrases given during the Indris song. And of course, it was natural, starting from what I said before, that we wanted to evaluate the inter-onset interval. So the gap in between the start of a unit and the start of the following unit. And what we've done is to measure all these gaps, let's say, all these intervals. And we were looking at variation during the song. And what we found was really surprising, because we had a difference between the sexes, and it's okay, we'll see this difference again later on. But we also had a difference in between the different phrases. So clearly there was a variation that was completely forgotten before, and we could actually look at and try to interpret, try to motivate, and try maybe to put in the mosaic of the evolution and of the development of the song. So here we concentrated, of course, on the within phrase intervals, but we also wanted to have a look at the between phrase intervals. That is what I showed you before is changing during development. And so we wanted to understand whether the coefficient of variation of females and males was significantly different. And as you can see from the picture, when we look at these two, within phrase and between phrase, IOI, inter-onset intervals, we got a significant differences for females having higher values compared to males in both IOIs between phrase and IOIs within phrase. This is telling us that not only males seems to be inheriting more the characteristics of the fathers, but also that they are much less variable in terms of the within phrase and between phrase inter-onset intervals. But also, when we look at the Indris song, this is a picture that is taken from a paper that we published 3 years ago. You got a lot of interchange between the different animals. You cannot use frequency, for example, to understand, oh, this is one animal, this is another one. You really have to track this information with a software, with a video, or with notes that you can take when you are in the field. You got to look at the animal to know what's happening over there, right? And we started thinking about interaction. And the interaction, and we know that dyadic interaction, when we are singing together, when we are speaking together, may adapt vocal abilities. And as we know very well, choruses may have a role in many collective situations, emotional synchronization, help people feeling as part of a group, right? And so we wanted to understand whether interaction can be some way evaluated, and maybe the degree of overlap in between the different individuals may change in relation with sex or role in the group. These are two animals interacting during the song, and you can see them in the video. So what we wanted to look at this stage was whether solo singing and overlap between individuals was providing some information, some difference maybe in between the different paired animals or non-paired animals. And look at this graph. So in this graph, you can see the percentage of solo singing is in this nice fuchsia color, and you see that paired male and paired female are those showing their values. So when it comes to singing alone in the chorus, their percentage of what they do is higher compared to non-paired males and non-paired females. When we look at the overlap, there's something very interesting, because overlap between these two is higher than any other diets we can consider. So if we consider pair male against, overlapping non-paired male or pair female against non-paired male or whatever, it's a significant lower values, right? So this is something that really may be important for us to know, but may be also important for neighboring groups, because the degree of overlap, we know from bird studies, they provide some information on what's going on in the group maybe, or what's going on in the interaction. And so this is, I think, an interesting information that we got to consider. Then, when we're singing together, you know, we have a lot of different rhythms, and one of the questions that is very important in the last years, I don't know if you're familiar with the books of Enke Noning or other colleagues, is what are the origins of musical rhythm? And so we know that the rhythm are ubiquitous, you know. You got rhythm in many different situations, moving arms, or dancing, or singing, or we also have circadian rhythms, you know, that are very important for everyday life. And we also know that, as I said before, rhythmic patterns may work as a social glue. And so it's a great chance, I think, to study this kind of themes, this kind of topics on non-human primates. And what we've been doing recently is to search for common musical traits across species. And so we were looking for categorical rhythms, which are temporal intervals between note onsets distributed categorically rather than uniformly. And we use this, in particular, this kind of hint to look at these rhythms, that is what we call small integer ratios. So for example, 1-on-1 is isochrony, but we also might have 1-on-2 or 2-on-1, right? And so we were looking at, for example, isochrony, because we know that isochrony is providing a low entropy message, and also provides information for conspecific about predictability of what happens next, right? It's the same for us. When we are tapping on the table, we got a perception that tells us that something is happening next, right? The beat. Searching for categorical rhythms, we calculated this ratio, okay? RK. RK is just an IOI divided by this IOI plus the next one, right? And so thinking about this in the song of the Indris meant to do something like that. So to divide within phrase intervals, WP, for WP plus between phrase intervals, like in this case, or within phrase intervals divided by within plus within, like in this case, or between divided by between plus between phrase intervals, like in this case, or between phrase intervals divided by between phrase intervals and within phrase intervals. And what we got in terms of same IOI as we said before, again, was a pretty much dimorphic, let's say, binomial distribution, okay, of this pattern. It was very interesting to look at this distribution, because we had 3 different peaks. And these 3 different peaks, this is a density distribution, PDF. We see that this pinkish color is telling us that the 1/2 small integer ratio and the 1/1 small integer ratio are significantly different than the values of the point distributed in between them. This is not true for the third one, which is a bit off-peak, but for the first two, we can say that there are at least two categorical rhythms that we could find for the first time in a non-human primate. And these categorical rhythms are those that we can search for example, in human music, right? So this is a very interesting result, and I'm happy to tell you that in 5 days, this result will be published in Current Biology. So let's go to a quick wrap-up, right? So, I'm there. I'm perfectly there. Multiple parameters encoded a metrosexual identity in the Indris song. And we see that there is potentially quite a different degree of variation in between males and females that, of course, must be investigated later. It can be somewhere related with dispersion of the animals, but it's very difficult to follow the dispersal of animals from their natal group because they are going in the forest very far, and it's not easy to follow them. Then we see that the changes during development are essential for adult sex dimorphism, as we've seen before. And we also see that Indris songs have rhythmic categories similar to those found in human music. So we really see that legendary creatures like these two can tell a lot about the evolution of music and musical abilities. But let me go again on the long term. So this is our research station in Madagascar. And when I think about the effort put in building this station, it's similar to the efforts I think has been put in this zoo, okay? And I remember very well the day we started the construction work. And I was in the middle of this empty area. And I remember asking our colleagues that were building up the whole things, are there hurricanes passing over here? And they said, no, Marco. There's no chance. We've been looking at historical weather forecast. There was no hurricane passing over here. They pass through the coast. They go over the south or over the north, but they don't come over this area. And then we made the roof 3 times over the last 10 years because of the hurricanes. So the third lesson we learned is never trust the weather forecast. And with that, I want to thank you for your attention. I want to thank a lot all my collaborators and colleagues. And let me stress that, of course, some of these colleagues are in the room here. And there is really a great set of female young scientists that are really kicking the ball. And if you're interested in animal behavior, you may have a look at our free software on the Boris website. Thank you so much.